Hi, I'm Razi Race. Today we will talk about Azure Blockchain Workbench. We'll provide an overview, and I have my friend and colleague, Cale Teeter. Cale, you want to introduce yourself?
Yep, this is Cale. So as Razi said, we kind of want to take you through a little bit of the why Workbench, why this product exists, and then a little bit of how it actually does what it does. So we're going to walk through a little bit of a demo here and just show you what it looks like, and again explain why this is important in the blockchain ecosystem.
Absolutely. So, just to set the structure here, we will do like a hello blockchain in the context of Azure Blockchain Workbench. We'll do more like hands-on, so probably gonna spend a little bit time talking about what the workbench is about and why Microsoft launched it. I mean, what's the reason behind it? Do you want to talk about it, Gil?
Yeah, I mean, the big thing here is as we started working with customers and people who started getting involved in the blockchain space, this stuff stemmed from cryptocurrency. So a lot of people understood things like Bitcoin or Ethereum, and they were like, "Oh, this is great! I want to start building an app with blockchain, so I just need these things." And it's way beyond that. It's not just the blockchain ledger, the underlying protocols and things like Ethereum and Bitcoin and Hyperledger and Corda and these kind of things expose, it is really a protocol layer. So we don't tend to have people come to us saying, I want to build a TCP application, which is the protocol for the web. So why would they come say, I want to build a blockchain application? It's kind of the similar thing. And so the idea is, as we started working with folks on this, we described to them that it's way more than just a ledger. We, are used to building web applications, having APIs. As Razi has on the screen here, some of the databases and event grids and all kinds of different things that happen inside Azure, like resource-wise, are important to build one of these apps.
Yeah, absolutely. I mean, I guess customers really appreciate if there's a there's a tool that help them just quickly create all these artifacts in the infrastructure side, so they don't have to deal with this and they can focus on the actual blockchain construct, like writing a smart contract and focus on the actual logic. So these are some of the services and artifacts that we create, like automate the creation using the workbench. Let's do this. Let's take this opportunity to jump right into some of the walkthroughs.
Yeah, and before we do that, I wanted to show people like where you can go get access to this stuff because we're kind of walking through a couple pieces here and want to make sure that people are aware where to find this stuff. So I just went to Azure.com, which redirects you here to Azure.Microsoft.com. If you click on Products, right here, Blockchain Workbench, right on the Feature tab. So if you click on that guy, you'll come into our main portal here for the Blockchain Workbench. You can see we have our documentation, some blockchain basics, also GitHub samples we'll kind of talk through, and then there's actually some labs up here too that allow you to kind of step through this at a slower pace.
Got it. So that's excellent. So we have the documentation, which is more like get started. If you It talks about the architecture. I think we can cover that in a bit here. But if you go back real quick on that initial page that we're showing, um, so the blockchain basics. If you don't necessarily know what blockchain is, I want to get started. The GitHub samples are actually interesting. I think we can quickly talk about that now, because we're going to be using one of the samples here. I think we're using the Hello blockchain, or the basic one that we have here. But you
Yeah,
want to talk about the samples?
yeah, and this is just a public repo that you can come out to. There's lots of documentation out here. This is where we publish the release notes. So we just released 1.2. So you can actually click in and look at how do I upgrade from a previous version. Here's a bunch of different samples. There's also like how do I give feedback back to the team. That's pretty active here as well. But the meat of this is if you drill into this blockchain workbench, and then inside of here you'll see a bunch of samples that you saw the headers for there in that other screen. But if you click on this top one, you'll actually see these are the actual projects that you can use. So there's an asset transfer here. There's a provenance tracking, like a supply chain type use case. There's a digital locker for like licenses. There's the Hello World kind of example that's super simple. There's a bunch of different things up here. But if you drill through some of these, you'll see that there's a bunch of files inside of here. And primarily the ones we're dealing with, we'll show you the interface here in a second, is this JSON file, which describes kind of the workflow, and then the Solidity file, which is our business logic. It's a smart contract. And then each one of these samples kind of typically walks through what are the application rules, the personas that are used in this app, what are the different state transitions that happen, what's the workflow kind of look like. Obviously, this one's a very simple one that's showing like a ping pong type response. But it's really good to just get the concepts down and start getting your feet wet with these. But once you start working through the hello world, moving up to some of these more advanced ones, for instance, the digital locker. If you take a look at this smart contract, it's not simple by any stretch of means. It's hundreds of lines long. There's actually a bigger workflow that goes along with this that I'm going to show on the screen here right now, which is
real quick. So we have the smart contract, and people who are listening to this or watching this who know Solidity. I mean, it's definitely feel like home, because Ethereum, that's pretty much the go-to language right now. But the JSON file that you showed, that is who generated that? Like, whose responsibility is to work with that?
Yeah, it's a good question. And what I did is just brought this up on the screen here so we can see it a little easier in VS Code. I'm in the Hello blockchain. I just synced that repo down, and here's the Solidity file. And you can see that basically it's, if you've written Solidity before, you have your typical pragmas at the top, and we have two contracts here. We're doing some inheritance here, and we have a Workbench base class, which is going to allow the workflow engine in Workbench to surface up things like the creation events, the updated events, and kick off the application. And then we have our actual meat here. This is our actual Solidity smart contract. In this case, it's pretty simple. We have a constructor, and then we have basically a send response and send request methods in here. So this is where we've read our Solidity code, and then in our JSON file that's associated with that, you see we name the application, we name what are the rules. So this is a key point. When you start building applications, especially if anyone's written smart contracts before, typically have to do with long things like addresses or hex addresses and things like that humans can't really process very easily. One of the things Workbench does is kind of ties those really complex addresses into things like Azure AD. So you have a friendly name, so I can talk to Razi as part of my blockchain as opposed to talking to 0x500 123.
So basically, these are reflective of identities in Azure Active Directory?
That's right.
Okay. Then we look at the workflows here. What are these?
Yeah, so the workflow is basically, think of this as like a state engine. So in the simplest case here, we're going to have a smart contract, and we're going to have a simple workflow that is going to keep track of the state of that workflow as it goes through. And so in this case, we're basically describing the different states that the smart contract can be in. We obviously have our constructor here that tells how to initialize it. We have any functions that we have defined. Remember, send response and send request. Right here they are. So the workflow knows how to tie into our smart contract. And then we have the different states that we have here, which are the request response, and you can see the transition. So what this is basically saying is, hey, we have a request state here that we can be in, and the next transition out of that would be the send response. Right? So basically this is describing, so you can see next states here, respond, and here's respond. And then this guy basically points back to request. So this one's a circular loop, but typically you could have as many kind of steps here as you need.
So this is like a actual workflow. So we have the states that are changing, and we can define as many states as we want, and they are tied to the smart contract that we wrote.
That's correct. Okay. Through that kind of integration you saw here where we define the functions right here is where we're actually tying into our smart contract.
Okay, and if you go back to the smart contract real quick, one more thing there, and the structure here is that you are more than welcome to write your own contract and the logic, but you have to always inherit with the base contract there, which is the Workbench base, and we don't necessarily recommend people to go and poke around here. Just leave it there. There's something to be used.
That's right. Yeah, this is going to trigger like the big things, because what you're thinking about here, and maybe this is a good time to tie out to our architecture diagram.
Yeah.
If you come up to blockchain again and go into blockchain workbench, and then go into our documentation section, right over here on the left side under concepts, this architecture, this is good when you start learning about this tool and what this thing can actually do. Basically, what we have here is our ledger on the right side. So in our case, Ethereum, proof of authority is what we're running right now. And then essentially, if you go clear to the left side, this is what the user would interact with. So the web app, the mobile app, whatnot. Using Azure AD creds to log in, they're going to hit an API. You notice that the web or the interface here that the user is using has no direct connection to the ledger. That's on purpose. So basically, we have a stable kind of API in front here that allows the application to talk through traditional means. And to Razi's point, this is kind of lowering the bar to developers, getting access to this. You start writing smart contracts, that's one piece, right? So you can define your logic. But when you start having to deal with these client libraries, in many cases, there's a bunch of them you're going to have to use, and you might not know which ones to use. There's a lot of open source software here, and so what we're trying to do is give people guidance over this is what works really well from a scalability, maintainability, security standpoint, and that's what you're seeing on your screen here now.
So basically, there's a REST-based endpoint that you, as a client, I will connect to that.
That's
the
right.
idea.
That's right.
And in terms of the authentication authorization, is it all based on the modern protocols like OAuth2 or OpenID Connect?
That's right. So the app itself wouldn't know that it's even talking to a blockchain. It looks to it's like it's talking to a REST endpoint using traditional OAuth.
Awesome. So from a learning curve standpoint, I mean, if there's a front-end developer wanted to work with blockchain on a blockchain project with that infrastructure set up, then they don't really pretty much know at that point. It's just an API call.
That's right.
So looking at the schema. Now, for the people who do want to write on the back end, like the smart contract, is there any specific guidance? I see Ethereum there, but we have other mention of other ledgers there, like Apple Ledger and Corda. So I think right now we support, the first release support the Ethereum.
Yeah, the offering right now, if you go provision this, and I'll show you where that is in the portal, is just using Ethereum by default. Now, our latest release allows you to basically point to custom spun up, ledgers. So if you go out and spin up your own Ethereum ledger and then you want to attach Workbench to it, that's totally possible in the recent release we just put out.
It's like a bring your own ledger.
Bring your own ledger, yeah, that's a good way to put it.
Okay.
The other ones here, yeah, these are future integration that we're working on. So the Hyperledger Fabric, the Cordas, Quorum, these kind of blockchains, these are the ones we're looking to target because they've been the most used by enterprises, which is our target kind of market here. And to Razi's point, the key vault, you'll notice it's kind of small on the screen here, but it's just a part of this as well. So basically, users are not in charge and having to kind of manage these keys and task with the key management themselves. They just use a traditional, OAuth, so they can use a username, password, their PIN, but they could also use multi-factor. And then once they authenticate into the system, every time that we're going to interface with the blockchain, in this case Ethereum, we'll do the transaction signing on their behalf using an HSM in Azure.
Awesome. I think this is something that we can cover in later talks in detail too. How would we do this? We jump, and I guess you wanted to walk through how to get this set up.
Yeah, to get started, basically there's two things, right? So the first thing is we need to spin up an Azure Blockchain Workbench instance. And what does that mean? It means the stuff you just saw in that architecture diagram, we're going to pre-provision a lot of that stuff for you. We need to have that base running, and then we take those artifacts that we were talking about before, the JSON file, the Solidity file, and we'll bring those over, and that will basically make this all work. So the first piece is we just come into the Azure portal. I just went to portal.azure.com, come in here and just type Azure Blockchain, and you see Azure typing automatically fills in. Lots of good documentation here about what we actually spin up. Good links here also out to our documentation, samples in case you're missing them, the support forums here with the product group on it, so in case you have any questions. And it just basically walks you through these few steps here, which are basically asking you for names and passwords, some Azure AD setup. It's all in the docs, so basically you can spin this up. I'll jump over to one that we already have running. So we have one spun up here already, and here's what you're looking at once this thing gets spun up. So you see there's not just like a VM or something like that. There's actually a bunch of assets. There's 24 that actually get spun up here, including things like web apps, the API itself. Remember they mentioned the gateway API. We have a bunch of monitoring services in here. We have Azure Key Vault. We have the different load balancers and network security groups. So point is, people were spending a lot of time out here spinning up this stuff, which really isn't good from a business standpoint. What we want to do is actually build an app and get the thing out there, as opposed to like working with infrastructure.
Yeah, I think that's a really important point to stress out here. Like, really, is that all of this infrastructure that needed, all these services that have been sort of like automatically provisioned for you. So you save time if you wanted to go and start working on a project, create an app, focus on the app and the scenario rather than just spending time getting these things done. So how do we get to this? So you already provision it, but if you wanted to start a new one, then we'll go and create a new resource, I guess.
That's right, and we would just answer all those questions. It takes about 20 to 25 minutes to spin up the whole thing. And once you have all these resources out, again, if you follow the docs, they'll kind of walk you through this, but I'll just show you here. You basically just sort by this typed column. You'll get the app services up at the top, and this is our website, our primary website that we're going to interface with.
What's next? So we have this up and running.
Okay, so yeah, we're over here, and basically this is what the interface looks like. You notice the URL is the same as the one I just showed you there. So basically, what we have here is our application running. In this case, I already created one. We'll create another one here so you can see how that works.
So this is the Hello World.
This is the Hello World. I already uploaded it. You can see I already ran one workflow through it, but let's create a new one. So basically, once you upload the application, you can create instances of the workflow. So in this workflow, we basically have a request and response. So it's going to say, what do you want for your request message? I'll say, hello demo. And basically, if I click on this button down here, you'll see it's basically creating an instance. Now this time it's 2 because I already had one that was provisioned down here. And what's actually happening here is quite a lot of stuff. So basically, I am interacting with a smart contract. I didn't have to know anything. Do you see any keys? There was nothing involved there at all. So basically what I did was use a simple web form to interact with a state transition. And so here's what my state looks like now. You can see we have a nice graphic here showing what our state transition, one step has been taken. It says Cale has recorded this action create. If I click on that, I can see all the details, including things like the addresses and the transaction hashes. So that's kind of interesting. We can actually see the underlying blockchain details.
So real quick here, so a couple of things. So this workflow or the state transaction that is happening within that workflow is based on the JSON file we saw earlier on.
That's right. We defined it in there.
Awesome. And then this address that you just showed, the actual Ethereum externally owned account address, this is the address tied to this Cale, which is basically an identity is based in Azure Active Directory.
That's right. And if you actually come up here and look at the app, you can see there's 2 members. Now in this case, I have myself added as both, but obviously we could have other Azure Active Directory users in here. And so you can see I have a role of a requester and a responder, and I can change this. I can remove it. So basically I made myself both a requester and responder. You can obviously add other members of your Azure AD group. And so Cale's the one who created this thing, and then Cale can actually take an action on it. So that's again defined in our workflow, as Razi said. And I can say, hey, I want to respond to that. And when I click on that, it'll say, hello response, hello demo response. And then basically you'll see again, you see this little spinning wheel. Because what's actually happening is it's taking my input that I gave here, it's looking at the workflow engine and basically saying the next step should be this. It's seeing that a smart contract's involved here, and I actually have to write something to the blockchain. In this case, I'm changing the state variable. And so it's signing the transaction for me. It's recording that into the blockchain. The blockchain is then picking that up, creating a block, taking that transaction into that block, and committing that transaction. So all that happened, and it's already done. So this is a proof of authority network, runs much fast. There's only 2 nodes in the existing, initial network that's running there. Obviously, you can scale that and change that as your requirements need.
And yes, it's important to clarify here that if we want to create our own network, we can do that and bring it and plug it in.
That's right. So that's a later, what Razi's mentioning is some of the latest releases we did for Workbench. This is basically a monthly release cycle. We've been adding features, and one of the first features we added was bring your own blockchain, or bring your own ledger rather. So basically you could go spin up or attach to another existing Ethereum network and kind of plug it into Workbench. Yeah, and the other thing I wanted to show here is if you want to create a new one of these, so basically let's take one of the other examples. So we did the Hello World one, but if I just have this synchronized down, but let's take asset transfer for instance. If we just browse into there, we see we have our 2 files, our JSON and our Solidity file. We'll go ahead and grab our workflow file, and then we'll grab our Solidity file here.
No, I'm just showing it.
Here. Okay. Okay, so we're back here, and we have that deployed. You see that we now have another application in here called Asset Transfer. And so if we click on that guy, you'll see there's no transitions. There's actually no people who have been added to this. Remember I said we have to add their personas in here. So again, in my case, I only have one user in my Azure AD here. I'll just add myself, just to demonstrate this. And you can see in this case we have multiple different kind of personas that can exist inside of this system. We'll just make Cale part of all of those. So he'll be everything. And what I'm actually doing here now is associating an identity with a kind of role in the system. This is our RBAC model. that we have as part of this. Now you notice that like a new button popped up here, new contract, so I can create an instance now. And I can say this is a test asset.
So the first thing you did, you basically add essentially members to this particular application.
Yeah, typically we just call them like participants who are going to be part of the system.
And again, I think it's maybe too advanced for this particular talk, but there is a RBAC, which is the Azure term for the type of security we provide.
Yeah, role-based access control. Yes. So we're tying actual users' identities to a particular role, so like an admin or a user or a buyer or something like that. So we can have multiple. Yeah.
Okay, so we just have a lot of Cales here, so that's great. We did that, and now we're gonna go and look into how this workflow works.
Yeah, and so I'll just walk through a couple of them here just to get a sense, because you saw in the Hello World how it worked. This one's very similar. So I can take an action, and again, I can pick what's the next thing I want to do. In this case, it's an asset transfer, so I can make an offer to buy this thing. I could modify it because I'm the one who offered it up. I could terminate the contract, so I can do a bunch of different things up here. In my case, let's just say make an offer. And you can see I can pick an inspector and appraiser, and then I can have an offer price of, let's say, 5. I had offered it up for 10, and then basically this workflow will go back and forth. It's just like a bartering type thing where I can say, hey, I was offering it up for 10, someone offered 5, should I accept that offer, kind of thing. The inspector is there to kind of validate, to make sure that it's a real item and that it's actually worth what we say it is.
So quick question, so who's assigning the address like to Cale leader? Let's say we pick a member here, where this address is coming from?
That's something we generate as part of the framework. So basically, again, you don't have to manage keys, so we'll just, when we see your persona come into the network, when we actually provision it there behind the scenes, we'll basically go provision an Ethereum address for you, an external account, and then you'll have a key pair that's in Azure Key Vault that allows you to do the signing.
Okay, and for the smart contract, let's say that for this one, we have the asset transfer. Let's say if you wanted to have something like multi-signature, so we want multiple participants to sign on something. So just a very high level, let's say we want to start it, and we can cover it on a different talk, but just to give an idea, you will basically start from the scratch, and then we basically going to start working on Solidity code. That's the idea.
That's right. So basically the idea is to have people focus just writing on their business logic, writing their smart contracts, a little bit of definition in that JSON file for the workflow to show like the personas and how they kind of tie together. But yeah, that's the basic concept, to get these things 0 to 60 much faster.
Just before we conclude, these are the links, what we shared. So these are documentation, GitHub samples, and then also the support forms. I think we didn't show them, but yeah, if you have any question, you're getting into issues, you can go and file the bug. All right, thanks, Cale. So we're probably gonna come back and do something else, and maybe we can write something or take a look deeper into Workbench. Thanks.
Thanks, guys.